Hello, I'm Matt Smee, Head of Agroecology at the Organic Research Centre.
And I'm Ella Bradfield, Research Scientist at ADAS. Today we'll be talking you through a range of physical weeding strategies.
Before we get into the techniques themselves, it's important to understand that physical weeding works within horticultural production as part of a wider strategic approach to how weeds are managed on farm. The action of deploying a single physical weeding approach will not solve issues that weeds present within horticultural production. What they are is a critical element within an integrated weed management plan. Integrated weed management is a holistic approach to weed control that combines multiple categories of tactics which can be drawn from biological, chemical, cultural and physical approaches. When stacking physical weeding strategies over time and space, they can serve to manage weeds in a way that minimises crop losses, reduces weed seed production and supports long-term agroecosystem health. It's not just about fighting weeds, it's about designing resilient systems that work in harmony with the crop, soil and climate. Key aims to consider when blending physical weeding strategies as part of an integrated weed management approach are minimising competition and interference with crops, reducing future weed pressures by targeting seed and seedling survival, preventing the spread of new problematic weed species, and improving indicators of agroecosystem health such as soil quality, water quality and energy efficiency. Integrating a range of physical weed control strategies can be effective at maintaining a weed-free environment during the crop's critical period, that crucial window when weed competition has the most impact on yield. This period varies by crop and environment, but aligning weed control actions with these strategies is essential. Many growers believe that integrating multiple weed control strategies is more costly and complex than simply relying on herbicides. While that can be true in some systems, it's far from universal. Studies show that the integration of physical weeding strategies can yield comparable or better returns, especially when long-term sustainability and resistance management are factored in. Physical methods play a crucial role in weed management in low-input systems, especially in organic production, small-scale systems, and places where herbicide resistance or environmental concerns limit chemical use. Today, we'll explore these methods, from hand tools to flame weeders, mulch to mechanical cultivation and beyond. We'll look at their benefits, limitations, and how they can be integrated into a robust weed management strategy. We'll explore how these methods apply practically, especially during that critical period of weed control, the essential window when crops must remain weed-free to avoid yield loss. This period is particularly important for cool season vegetables like carrots, beetroots and brassicas. These crops have slow canopy development and are typically grown at a 30 to 70 centimetre row spacing, with tighter spacings within rows. That setup makes inter-row weeding easy, but intra-row weeding remains a big challenge. To manage weeds effectively during the critical period, physical weeding can be grouped into three timing-based categories: pre-emergence strategies, post-emergence inter-row cultivation, and post-emergence intra-row cultivation. Let's go through each stage and look at the physical approaches you could deploy. The false or stale seedbed technique is a simple yet powerful way to manage weeds without chemicals, especially in outdoor horticulture crops. The process begins by preparing the soil for planting, just as you normally would, but instead of sowing immediately, you pause. This delay allows weed seeds near the surface to germinate, triggered by exposure to light, moisture and warmth. Once the first flush of weeds appears, they're eliminated using shallow tillage or flame weeding, and the crop is sown into a cleaner, low competition environment. This early intervention is crucial because it removes weeds at the crop's most vulnerable stage, right after germination, when competition for water, nutrients and sunlight can be severely impacted during the crop's establishment. By reducing the weed seed bank before planting, farmers can boost yields and lessen the need for post-emergent weed control later in the season. Harrowing is most effective when weeds are at the white thread or cotyledon stage, disturbing them just before they become resilient. Flame weeding, on the other hand, uses propane burners to kill small broadleaf weeds and can reduce weed biomass by as much as 90%. These techniques are especially well suited to slow germinating crops like carrots, which provide a wider window for weed control. In faster emerging crops, the narrow time frame between weed and crop emergence makes flame weeding less effective. That said, there are trade-offs. The technique demands additional field passes, meaning more labour, fuel and equipment use. Weather also plays a key role. If it's too dry or cool, weeds may not germinate as expected, which can reduce the method's success. On farms with short growing seasons or limited access to machinery, this extra step might not be practical. Still, when conditions align, the false seedbed technique, supported by well-timed harrowing or flame weeding, is a smart, sustainable strategy to reduce early weed season growth and create stronger, healthier plants from the start. Flame weeding is a physical strategy that can be deployed to create a stale seedbed. The technique uses heat, not fire, to kill weeds. Instead of burning plants, this technique exposes them to intense heat for a short moment of time, just enough to rupture the cell walls. The sudden heat causes the water inside the plant to vaporize, leading to cell collapse. Without functioning tissues, the plant can't transport nutrients and the root system eventually dies out, dries out and dies. It's especially effective against young, broad-leaved annual weeds and seedlings, but not effective on mature perennials or established grasses, which tend to bounce back after treatment. The equipment varies. Larger fields use tractor-mounted propane burners, while smaller farms can utilise hand-pushed flame weeders. The key is operating at the right speed, usually 2 to 4 miles per hour, to ensure the flame hits weeds just long enough to damage the plant cells. For slower germinating crops, like carrots, a second pass may be needed. Marker crops like beetroot, which germinate faster, can help time that second application. Flame weeding comes with both pros and cons. It's a great chemical-free option that supports organic systems and can reduce the need for labour-intensive hand weeding, but it does come with costs: propane usage, specialised equipment and operator training. Windy or wet conditions may reduce its effectiveness. The machinery must be carefully adjusted for optimal results. When used correctly, flame weeding is a powerful, sustainable tool in integrated weed management, especially for growers as they look to reduce chemical inputs. Post-emergence mechanical weeding. Mechanical weeding is a wide-ranging physical strategy. One of its most effective applications is during the post-emergence phase, when crops have sprouted but are still in the early stages of development. At this point, inter-row mechanical cultivation becomes the go-to strategy. Tools like flexible tines, steerable hoes and rolling baskets can precisely target weeds between rows. Timing is everything. Mechanical control is most effective when weeds are at their weakest, the white thread or cotyledon stage. If weeds are allowed to develop beyond 4 true leaves, they become much harder to dislodge. Precision is also critical, especially with young crops that are still establishing. Equipment configuration needs to match crop spacing and developmental stage to avoid damage. For shallow-rooted annual weeds, tine and harrow combs work well. For tougher or deeper-rooted weeds, duck-footed blades can sever roots effectively. Modern advancements are making this process more accurate and efficient. In Greece, for example, a mechanical weeding system was developed using a suspended cultivator guided by a Raspberry Pi-based computer vision system. It can detect crop rows in real time and adjust the cultivator's position using a hydraulic cross-displacement mechanism. This allows for highly accurate weed control between rows, even if the tractor veers off slightly. Similarly, machine vision and spectral imaging are being integrated into electronic steering systems, which can guide cultivators at a speed of up to 5 to 6 kilometers per hour, with positional errors under 30 millimeters. These systems not only improve precision, but also reduce operator fatigue, especially important in large-scale operations. That said, manual steering is very much the norm for small-scale growers. When paired with strategic crop rotation and careful timing, mechanical cultivation becomes part of a robust integrated weed management plan, but it's not without its challenges. Effectiveness depends on dry soil conditions, and rocky or compacted soils can impact results. Sensitive crops may be harmed by aggressive cultivation, and repeated passes can disrupt soil structure or disturb ground-dwelling wildlife. Equipment costs and fuel use are also concerns, especially for smaller farmers. Still, when done right, and especially when combined with emerging technologies, mechanical inter-row weeding offers a practical, precise and sustainable approach to post-emergence weed control.
Intra-row mechanical weeding presents an important opportunity for sustainable, chemical-free weed management in horticultural cropping systems. Unlike inter-row weeding, which is relatively straightforward, intra-row weeding targets weeds growing within the same line as the crop, often the most labour-intensive and sensitive area to manage. 3 key mechanical tools have emerged as effective solutions for intra-row weed control: finger weeders, brush weeders and torsion weeders. Finger weeders consist of ground-driven rotating rubber or polyurethane discs with flexible fingers that penetrate the soil surface, uprooting weeds directly next to the crop plants without damaging the crop itself. These are particularly effective at the white thread to cotyledon stage of weed development. Because of their gentle touch and adjustability, they are widely used in crops like carrots, onions, spinach and lettuce. They are best suited for precision-sown row crops with consistent spacing and work optimally at slower speeds, typically below 2 kilometers per hour. Brush weeders use rotating vertical or horizontal nylon or fiberglass brushes to disturb and uproot young weeds in and around the crop line. The flexibility of the brush allows for close contact with the soil and crop stems without causing damage. Studies show that in crops like carrots, brush weeders can remove up to 90% of intra-row weeds when used under ideal conditions. Torsion weeders utilise pairs of spring steel rods that sweep just under the soil surface from both sides of the row, disturbing the soil and uprooting weeds within the crop line. They rely on tension and flexibility to bend around the crop stems, making them suitable for a wide variety of vegetables. They are inexpensive and easily added to toolbar cultivators, most effective when weeds are in early stages and soil is dry and loose. As with finger weeders, they require precise setup and slower travel speeds to protect the crop. These intra-row tools are often used in conjunction with inter-row cultivation systems to provide full field coverage. The increasing use of camera-guided steering systems and GPS alignment is enhancing the precision and efficiency of these methods, especially in small to medium-scale horticultural farms where manual weeding is time-consuming and costly. Finger, brush and torsion weeders each play a critical role in reducing the dependency on chemical controls, promoting a more sustainable and efficient approach to intra-row weed management in high-value horticultural crops. Robotic weeding is rapidly transforming weed management in horticulture, especially when it comes to the challenge of intra-row weeding, where weeds grow directly within the crop line. These systems, whether autonomous robots or tractor-mounted machines, use advanced cameras and sensors to detect weeds and control them through mechanical tools or lasers. One of the biggest advantages is the drastic reduction or even elimination of herbicide use within horticultural systems. Autonomous robot weeders can reduce labour demand and allow for consistent, low-input weed management across large areas. Laser weeding is particularly promising. It avoids soil disturbance, helping maintain soil structure and prevents triggering new weed germination. Unlike herbicides, lasers can be used at any crop growth stage without concerns about crop safety or chemical residues. In the UK, commercial options include the solar-powered FarmDroid FD20 and the Earth Rover system. These robots are lightweight, reducing soil compaction and fuel use, Other tools like the Stout Smart Cultivator and Garford RoboCrop are tractor-mounted precision weeders already being used in field vegetables. Companies like Eco-Robotics and Carbon Robotics have also developed systems that target weeds and either apply targeted herbicide or eliminate weeds with lasers. These technologies represent the future of precision, sustainable farming, making weed control more efficient, more accurate, and far better for the environment. The FarmDroid FD20 is an innovative robotic weeding and sowing system originally developed to support organic sugar beet production. Through precision sowing, which records the GPS position of every seed, it enabled blind weeding, removing weeds early, even before the crop emerges. There's no need for expensive cameras or image processing. The robot simply knows exactly where each plant will grow. This precision approach is not limited to sugar beets. It works well for over 50 crops, including vegetables like onion, spinach, carrot, kale, cabbage, and chicory. As long as the crop is grown with at least 22.5 centimetre spacing, the FarmDroid can be deployed. Demonstrations in England have shown the FarmDroid seeding onions in clusters with 15 centimetre spacing. Within days, blind weeding begins, even before the onions are merged, using shallow wires placed just 1 to 2 centimetres underground and guided by seed GPS positions. It navigates these wires within 40 millimetres of clusters to avoid damage during intra-row weeding. The robot is solar powered and CO2 neutral. It charges via 4 solar panels, generating roughly 20 kilowatts daily, allowing for 18 to 24 hours of continuous operation. It weighs less than 1,000 kilos, causing minimal soil compaction. Performance-wise, FarmDroid sows at about 0.2 hectares per hour and weeds slightly faster, around 0.27 hectares per hour. It can cover roughly 6 to 6.5 acres per day. With 4 weeding passes annually, one robot can manage 20 to 25 hectares. Farmers report substantial gains, yield increases of 40 to 60% in organic beet and spinach fields due to ultra-precise intra and inter-row weed control, uniform plant spacing and minimised crop competition. Combined savings on labour, herbicide, fuel and machinery make the return on investment compelling, with potential payback periods as short as 1 to 2 years. Still, there are limitations. The upfront cost is around €100,000. The system is slower than conventional tractors and less effective on fields with rocky or uneven terrain. It also requires sufficient time windows for sowing and repeated weed passes. In dry seasons, shallow hoeing can disturb crusted soil, potentially clogging the weeding tools. Additional considerations around physical weeding strategies for horticultural crops are reduced tillage and conservation systems. Living mulches are a forward-thinking, ecologically beneficial approach that can work to suppress annual weed populations. Instead of traditional inert materials like straw or plastic, living mulches in horticultural systems consist of actively growing low plants, often legumes, planted between primary crops once they are well established. These mulches suppress weeds, improve soil structure, conserve moisture, fix nitrogen and support biodiversity, offering a sustainable alternative to synthetic inputs. When managed well, living mulches contribute to soil health and environmental resilience. They reduce erosion, improve organic matter and reduce the need for synthetic fertilisers, yet they must be carefully managed to avoid competition with the cash crop. Mulches sown too early in the cash crop's life cycle or mulches with overly vigorous growth can limit crop yields through root zone competition. Living mulches are best suited to vertically growing or wide-spaced crops such as brassicas, cucurbits and protected crops like tomatoes and peppers. Their high canopy allows light penetration to the mulch without shading the crop excessively. Low-growing legumes such as red or white clover or sub-clover species like Oper8 or Aber-Herald can be considered. These species stay relatively prostrate, suppress weeds effectively and can contribute nitrogen, but must be chosen for slow or low competition traits to avoid resource conflict. The simplest approach to establishing a living mulch in horticultural crops is to undersow an established crop when its root systems are developed enough to not suffer from competition. Sowing is best done in the interrow space, leaving enough space around the crop to allow the mulch to spread over the growing season. Strip tillage can be paired with established living mulch systems. By tilling only the narrow crop row strip and leaving mulch undisturbed between rows, it reduces competition, preserves soil structure, and targets weed control. Mowing or shallow rototilling between rows during the growing season also keeps the mulch in check without disturbing crop rows. However, strip tillage can create unfavourable competition with the cash crop for light, water and nutrients, particularly early in the season. This can lead to a yield penalty that makes the choice to strip tillage undesirable. Living mulches and strip tillage presents a potential pathway to suppressing weeds and improving ecosystem services. However, they require careful planning and deployment to avoid yield penalties. It is recommended to trial the approach in a small area on farm to build a system that works for your specific on-farm requirements. To wrap up, physical weeding plays a vital role in integrated weed management, especially in systems trying to reduce herbicide usage. From pre-emergence methods like false seed beds and flame weeding to post-emergence strategies, both inter and intra-row, we've explored how combining tools like tine weeders, finger weeders and robotic systems can maintain weed control during critical crop growth stages. Each method has trade-offs, but when used strategically, they can minimise weed pressure, protect yields and support soil health. Emerging technologies such as robotics and novel approaches like living mulches point to a more sustainable and precise future in weed management. The key takeaway? No single method is enough. Success lies in smart, tailored integration. Thank you for watching. Don't forget to review the Oper8 website for more information on the techniques outlined in today's talk.